Hi everyone. So today we are going to see the last topic in this chapter, real numbers. Okay, so we have revisiting rational numbers and their decimal expansion. Okay, so first we'll see what are the decimal expansions of rational numbers. Okay, the decimal numbers, we know either it will be terminating or non-terminating. If it is terminating, so for example 2.5, 3.28, the decimal number terminates, ends, then the numbers are rational numbers. Okay, suppose if the decimal expansion is non-terminating, then we have two cases, that is the numbers either it will be repeating or non-repeating. Okay, so non-terminating and repeating, see there 2.5555. So the number 555 is repeating and it is not terminating, it will be going on. Same way 1.323232, the number 32 is repeating and it is not ending, it is not terminating. Then those numbers are rational numbers. The next case, non-terminating, non-repeating. So here you see pi 3.14159265. Here that number does not terminate, also it is not repeating. Then the numbers are irrational numbers. These all already you have studied. So the decimal expansion of rational number will be either terminating or non-terminating, repeating. So the decimal expansion of real number is either terminating or non-terminating, repeating. Okay, in this topic, in this exercise, we are going to find whether a rational number without doing, actually how we find whether it is repeating or non-repeating. So we do the division. Okay, last year you learned. So first division you see 10 is divided by 3. So the quotient you get 3.333 so on. So here the decimal expansion is non-terminating, repeating. Second one you see the decimal expansion is terminating, you get 0.875. And third one is non-terminating, repeating. So here we do the division and we find whether it is terminating or non-terminating. So now in this exercise we are going to find whether it is terminating or non-terminating without doing the actual division. We will not do any division at all, but we will find whether it is terminating decimal or non-terminating repeating decimal for rational numbers. Okay, so now, so what is the condition, what is the fact to find whether it is terminating or non-terminating? See, suppose p by q is a rational number. Okay, rational number definition we know which can be written in the form p by q, where p and q are integers and q not equal to 0. So in the rational number p by q, if the denominator, that is q, if it is in the form 2 power n 5 power m, then the rational number will be terminating. Okay, this is the theorem, very simple and very important. Okay, you see the first example, 13 by 3125. Okay, so we'll take the prime factorization of the denominator. So prime factorization of the denominator 3125, the prime factorization is 5 power 5. Okay, so here the denominator is 5 power 5. So but in theorem it is given 2 power n 5 power m. Then only it terminates. Okay, so here 2 power n here is 0. Okay, n here is 0, so it is in the form 2 power n 5 power m, therefore it is terminating. So what I want to tell you is, so if the denominator, if the prime factorization of the denominator, if it is in the form either 2 power, it should have 2 or it should have 5 alone, or it can have both 2 and 5 but not any other number. If you have any other number like 3 or 7 or 13 or 11 in the prime factorization, then the decimal expansion will be non-terminating, repeating. Okay, so see the second one, 17 by 8, which is equal to 17 by, the prime factorization of 8 is 2 power 3. Okay, so here it is in the form 2 power n 5 power m, therefore the decimal expansion is terminating. Okay, you see third one here, 64 by 455. So 64 by 5 into 7 into 13. So we have 7 here, 13 here. Therefore, it is not in the form 2 power n, 5 power m. Therefore, it is non-terminating, repeating. So what you have to keep in mind is, if in the prime factorization of the denominator, if it has 2 alone, then it is terminating. If it has 5 alone, then it is terminating. If it has 2 and 5 both, then it is terminating. Otherwise, it is non-terminating, repeating. Okay, so now we have the exercise. So the first question is, I should find whether the rational numbers given are terminating or non-terminating, repeating decimal. Okay, second question also we have to do with the same first sum problems. Write down the decimal expansion of those rational number in question number 1 above which have terminating decimal. So I should find, if it is terminating, I should find the decimal expansion also. Okay, so that we will see here for few problems. So first one we already saw. So 13 by 3125. So 13 by 5 power 5. So since it has only 5, therefore it is terminating. Okay, now how to find the decimal expansion? Okay, so here first what you do is 13 by 5 power 5. You see how many 5s are there in the denominator. There are 5 5s. So how many 5s are there? I will multiply that many 2s. Okay, 5 power 5 is there. So I will multiply 2 power 5 because to bring 10 power 5 in the denominator. Okay, and we should not do the actual division. Without doing the division, we are finding the decimal expansion here. So how many 5s are there? That many 2s we multiply and bring 10. Okay, 5 power 5 is there, so we multiply 2 power 5. So then it will become 10 power 5. Okay, so when I multiply, I should divide. So 2 power 5, 2 power 5. So numerator 13 into 2 power 5 is 32. So we get 416. So we get 416 divided by 10 power 5 is 1 lakh. So now see the denominator, how many zeros are there? Okay, there are 5 zeros. Then you have to keep the decimal point before 5 numbers on the numerator. So we have 416, it has only 3 digits. So we put 2 more zeros in front and keep the decimal point in front. So the answer is 0.00416. Okay, so there are 3 types of question asked here. Find whether terminating or non-terminating. Next is find the decimal expansion, and next one is find after how many decimals it will terminate. It is not in the textbook. Okay, this is also asked in board exam. After how many decimals it will terminate. Without doing the division, we can find. Okay, so here you got the answer 0.00416. 5 decimal it terminates. Okay, without doing this itself, we can find after how many decimal it terminates. You see the first step, 13 by 3125 equal to 13 by 5 power 5. So you see the highest power in the denominator. See the highest power in the denominator. What is the power there? 5. So the decimal terminates after 5 decimal. Okay, now second one, 17 by 8. 17 by 8 is 17 by 2 power 3. Okay, so it has 2 alone, therefore it is a terminating decimal. You can see you have 2 power 3. So highest power in the denominator is 3. Therefore it will terminate after 3 decimal. Okay, now we'll find the decimal expansion. Okay, so 13 by 2 power 3. There are 3 2's. So I'm going to multiply 3 5's. So I'll multiply and divide by 5 power 3. Therefore you will get 10 power 3 in the denominator, that is 1000. So on numerator you multiply 7 into 125. So you get 2125 by 1000. So there are 3 zeros in the denominator. So you keep the decimal point before 3 numbers. Okay, there is one more point you have to keep in mind. Okay, so here when we are finding the prime factorization of the denominator, okay, so to be in the safer side, to get the correct answer, please try to get the prime factorization of the numerator also, because sometimes the number may get cancelled and the answer may change. Okay, we'll see that example also. Okay, did you understand this? Now, see the third one. There it was only 13 and 17 prime number. That's why I didn't take the prime factorization. It is only prime number. You have only 13 and 17. Here 64 by 455. Okay, I took the prime factorization of both numerator and denominator. So 2 power 6 by 5 into 7 into 13. So you have number other than 2 and 5 also. We have 7 and 13. Therefore, it has non-terminating repeating decimal. Okay, now 8th one, it is the best example to say why we have to take the prime factorization of the numerator also. Suppose here you see 6 by 15. 6, what is the prime factorization? 2 into 3. 15, what is the prime factorization? 3 into 5. Suppose if I am not taking the prime factorization of numerator, then I have what is in denominator? 3 into 5. So seeing 3 other than 5 is there. Therefore you will conclude that it is non-terminating repeating. But what happens here is 3 and 3 will get cancelled. So the rational number is 2 by 5. So when 2 by 5, now 5 alone is there. Therefore it is terminating decimal. So the answer is changing. So please find the decimal prime factorization of numerator also. Okay, now 2 by 5. What is the power of 5? 1. Therefore, it will terminate after only one decimal. So you see that 2 by 5. So 1 5 is there. So I'll multiply and divide by 2. So you will get 4 by 10, which is 0.4. Okay, now 7th subdivision, 129 by 2 square, 5 power 7, 7 power 5. So you have in the denominator, the prime factorization of denominator, you have number other than 2 and 5 also. Therefore, it is non-terminating repeating decimal. Okay, so now I have given the answers for the other subdivisions also. 15 by 1600, you can see that you have 2 power 6 into 5. So the decimal will terminate after 6 decimal and you get the decimal expansion. 29 by 343, it is a non-terminating repeating decimal. Then 6th subdivision, 23 by 2 power 3, 5 power 2. So it is terminating and it will terminate after 3 decimal. So the answer is 0.115. 9th subdivision, 35 by 50. So 7 by 2 into 5. Okay, it is terminating, you'll get 0.7. Then 10th one, 77 by 210. It is non-terminating, repeating. Now 3rd question, the following real numbers have the decimal expansion as given below. In each case, decide whether they are rational or not. First, I have to find whether they are rational or irrational. Second, if they are rational and of the form P by Q, what can you say about the prime factor of Q? First, I should find rational or irrational. Then if it is rational, I should say what will be the prime factors of Q. That is whether it will be in the 2 power n, 5 power m form or not. Okay. First one, 43.123456789. So it is terminating. So since it is terminating, therefore it is a rational number, and definitely since it is terminating, the denominator will be in 2 power n, 5 power m form. Okay. Then second one, so second one you see it is going on, it is non-terminating, also it is not repeating, therefore it is irrational number. Third one, you can see the bar there, so it is non-terminating and it is repeating, therefore it is a rational number. But since it is non-terminating repeating, then the prime factors of Q will not be of the form 2 power n, 5 power m. Okay, that's all. The chapter gets over. Thank you.